What up, my people? After watching this video, you'll be able to solve a word problem using quadratic equations with irrational roots. Let's get it. Let's begin with some vocabulary. For one, we have f of x, the function when x is equal to blank. That's the same thing as basically y, which is the output of a function. The standard form of a quadratic equation is f of x is equal to ax squared plus bx plus c, where f of x is equal to 0. The quadratic equation is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's going to be the values for x, or the potential values for x, because you could have one solution or two, or none. So for this example, a ball is thrown from an initial height of 1 meter with an initial upward velocity of 20 meters per second. The ball's height h in meters after t seconds is given by the following equation. H is equal to 1 plus 20t minus 5t squared. Find all values for t for which the ball's height is 6 meters. Round your answer to the nearest hundredth. So when I read this, I'm looking for some key statements when I'm doing this. The first thing that I'm looking at is what the variables stand for. So in this case, h is going to be the height, t is going to represent the time, and then I look at the drawing. In the drawing, it's saying we have an initial height that a ball is thrown. So the ball is going to be going upward at the beginning of the throw, and then it's going to reach its vertex or the highest point, and then it's going to start to come back down. So the question is basically saying, hey, we have two spots where this ball is going to be at 6 meters, and we need to figure out and calculate where that time would be. For this problem, we're going to be using the quadratic formula that they gave us, and we're going to plug in 6 for the h. So our equation is going to be now 6 equals 1 plus 20t minus 5t squared. When we're dealing with these problems, we usually like to put these in standard form. So we're going to go from left to right with our decreasing exponents. So that's going to be negative 5t squared plus 20t plus 1. And all of that's going to be equal to 6. The next step is to get rid of the 6 on the left side of the equation, because we need to have one side equal 0. So we subtract 6 from both sides. And that gives us 0 is equal to negative 5t squared plus 20t, and then 1 minus 6 is going to be negative 5. All of the coefficients and the constant are all divisible by 5. So if I can divide everything on this side by negative 5, that would simplify this greatly, so I don't have to deal with bigger numbers. So when I divide both sides by negative 5, I'm going to end up with 0 is equal to t squared minus 4t, and then negative divided by negative is positive, so that becomes 1. So now that I have everything equal to 0, I can plug all these values into the quadratic equation and then solve. So because there's nothing right here, that's really going to be a 1. So that's going to be my A. This is going to be B. And this is going to be my C. So let's rewrite it up top over here so that way it's not ridiculous. A equals 1. B is equal to negative 4. And c is equal to 1. Then I plug it into the quadratic equation. We have negative b. So negative of negative 4 times 1 times 1. All of that divided by 2a. I simplify everything, and I try to simplify it as much as I can under the radical. So negative times negative becomes positive, so that becomes 4. Plus or minus, we have negative 4 squared is going to be 16. And then 4 times 1 is going to be 4. So we have 16 minus 4, all divided by 2. And then we have 4 plus or minus the square root of 12 divided by 2. So that's our time. So now we need to split this up. So we have 4 plus the square root of 12 divided by 2. And then we have 4 minus the square root of 12 divided by 2. When we plug this into our calculator, taking care of the numerator first and then dividing it by 2, we end up getting 3.7320 for the first one. And then we also have 0.267. And then if we round it to the nearest hundredth, that means that we're going to be rounding down because 2 is smaller. And then we're going to round up because 7 is greater than 5. So that means we have 3.73 and we have 0.27, and that's our time in seconds. For our next example, a ball is thrown from a height of 45 meters with an initial downward velocity of 5 meters per second. The ball's height h in meters after time t in seconds is given by the following. H is equal to 45 minus 5t minus 5t squared. How long after the ball is thrown does it hit the ground? Round to the nearest hundredth. So if we look at the drawing, we're throwing the ball off the top of a building, and we just need to know when the ball's height is equal to 0. Because 0 is where the ground is. We start from 0 and then we're going to be going forward in time. So there's going to be only one solution when we deal with this equation as well. So if you guys are doing this and you see that you're using you have a visual that's available to you, you can look at that visual to help you out with this. So we're going to be replacing h with 0 because 0 again is the time when the ball hits the ground. So 0 is equal to 45 minus 5t minus 5t squared. I need to put this in order, so we reorganize it. So it's negative 5t squared minus 5t plus 45. And all of this is equal to 0. So that means that this is actually my A, this is my B, and this is my C. So all I'm going to do is plug that into my quadratic equation and then simplify as much as I can. So I have negative of negative b, or I have negative b, so it's negative of negative 5. I have negative of negative 5 plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. I'm going to simplify everything under the radical and everything on the numerator as much as I can. I have negative 5 squared, that's 25, and then I have 4 times 45, which is a lot. I have 4 times 45 times 5. When I plug that in, I have 25 plus 900 after I multiply 4 times 5 times 45. And when I add that together, because I am subtracting a negative, that becomes a positive. That's going to become 5 plus or minus the square root of 925. All of that divided by negative 10. So technically that's my solution. And I need to figure out what the actual times are. So I'm going to plug that in. So I have 5 plus the square root of 925 divided by negative 10. And then I also have 5 minus the square root of 925 divided by negative 10. If I plug this in, I'm going to get negative 3.541. And then for the second one, if I plug all of this into my calculator, I'm going to get 2.541. Notice, because this value is negative, it doesn't exist. Because again, I can't travel backwards in time. So from the time that I throw the ball to the time it hits the ground, it's going to be 2.541, and if I round that to the nearest hundredth, I have to round down. So that's going to be approximately 2.54 seconds. And that's it. All right, go ahead and pause the video and take a screenshot. There will be a link to the solution in the description. Please like if you understood the tutorial, and share and subscribe for more tutorials. Thank you for taking the time to invest in yourself and making your weakness a strength. Ashe.